Hello everyone, I am Akash and you are watching my YouTube channel Nia Labs. So guys, we are going to talk about Diophantine equation and combinatorics application today. So Diophantine equation are like equation in variables x, y, z or something else where we have constant that x, y, z are essentially integers. For example, in this question, I have an equation x plus y plus z is equal to 10 where x, y, z are non-negative integers. So I need to find out number of such solutions where x, y, z are non-negative integers and sum of these three integers is equal to 10. For example, 1, comma 2, comma 7 is one of the solution. Okay, so how many such solutions we can find out? So there are many ways to calculate it. One of them is using generating functions in discrete mathematics. So there are some other as well, like some simple methods suggested. Some people call it like beggar coin method, or some people call it pirates methods. So we say there are three beggars named X, Y, Z, and we have 10 identical gold coins. So number of solution will be equal to number of ways in which we can distribute these 10 identical coins in these three beggars X, Y, Z. Okay. So let's say very simple situation where I have a strip, okay, a strip upon which I have pasted these 10 coins. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in order to distribute these 10 coins among these three beggars X, Y, Z, I need to make three parts. So in order to make three parts, I have to make how many cuts? Two cuts are required. Let's say first cut and second cut. Okay, so by doing these two cuts, we will be able to make three parts of this strip. Okay, three parts of this strip. And according to these two particular cuts, we have value of x is equal to 4 and value of y is equal to 3 and value of z is equal to 3. So we have 4 comma 3 comma 3 is one of the possible solution. So in how many ways we can place these two cuts in between these 10 coins? So answer is simple. This will be equal to arrangement of these 10 identical gold coins, okay, and two cuts. So more or less the answer is arrangement of two kinds of things in which we have 10 gold coins and two dummy coins. So this particular arrangement can be done in how many ways? We have simple methods in combinatorics or permutation combination, arrangement of identical things, that is 12 factorial divided by 2 factorial, 10 factorial. 10 factorial for the 10 gold coins and 2 factorial for the 2 dummy coins. So the answer is 12C2. Okay, or I can say 10 plus 3 minus 1C2. Okay, or 3 minus 1. So what we are doing, if you want to distribute 10 identical coins among three beggars, we just need to add two dummy coins. Okay, one lesser than the number of beggars or the pirates. So we have a very simple method. The answer will be for this particular question is 12C2. Okay, if we have like x plus y plus g plus w and equal to 20, so number of ways to distribute these 20 coins or number of possible solution of this particular equation where x, y, z, w are non-negative integers. Okay, non-negative integers. So we have four beggars, so we just need to add three dummy coins. So my answer will be 20 plus 3 C3. Okay, one less dummy coin. So answer is 23 C3. C is just simply, you may also write, some books have notation like this, 23 C3. Okay, so let's have some further constraint about this particular problem. So if I have x plus y plus g plus w is equal to 20. Okay, now I have constraint that these four variables x, y, z, w are natural numbers, or you can say positive integers. So now x, y, z and w can assume only values like 1, 2, 3 and on so. Okay, so we can't assign 0 to any of the numbers, so we have to assign at least 1 to these four numbers. So there are like particular ways either you can write this particular number as x dash plus 1, y dash plus 1, z dash plus 1, w plus 1, so that my new equation will be x dash, y dash, z dash and w dash will be equal to 16. Okay, so now I can apply the same constant, like the x dash, y dash, z dash, w dash can have any value from 0 to 16, each of them. So my required answer will be equal to 16 plus 3c3. Okay, that is 16c3. Easy. Or otherwise we could say that let's just distribute one coin to each of the beggar, as they will be having at least one coin. So just distribute one coin to each of the beggar, which can be done in one way because all the coins are identical. Okay, there is no difference between the coins, so just distribute all the beggars one coin each. So you will be having 16 coin, which you can distribute in any number of ways. So the answer will be 16 plus 3c3, the same way I did 12c2. Okay, now add more constants, some inequations. If I say a very interesting problem, x, y, w plus z is equal to 20. And my constant is that x is always greater than 2, y is greater than 3, and w and z both are greater than equal to 1. All are integers, okay, positive integers. So definitely you can replace this particular thing as x dash plus 2, this as y dash plus 3, w dash plus 1 and z dash plus 1 is equal to 20. So now I have new equation, x prime, y prime, w prime, z prime is equal to 2, 3 and this is 7, this is 13. So this x prime, y prime, w prime, z prime can have any number of any value from 0 to 0, 1, 2, 3, something like that, non-negative integer. So I can again distribute this thing as 13 plus 3c3, which you can also write 16c3. Okay, sorry, this is, yes, 16c3. Here my answer is 19c3. Okay, so answer is 16c3. Or in some other words, you could say like assign 2 coins to x and 3 coins to z and corresponding conditions. So we will be having remaining 16 coins, 13 coins with us, which can be distributed in any number of way we want. So the answer will be 13c plus 3c3. So now few inequations. Let's say if I have x plus y plus z less than equal to say 6, and my x, y, z are non-negative integers. Okay, non-negative integers. So number of possible solutions of this problem, x comma y comma z. So number of possible solution of this particular problem. So with one of the ways, like make constants x plus y plus z less, that it can be equal to 0, it can be equal to 1, it can be equal to 2, 3, 4, 5 or 6. So in each of the situation we have constants. So we can say my answer in this case will be number of beggars, 3 beggars. So we just need to add 2 dummy coins. So 0 plus 2 C2. In this case 1 plus 2 C2, 2 plus 2 C2. So going in the same manner we will be having 6 plus 2 C2. So I have a series which I need to sum up, which is 2c2 plus 3c2, 4c2 plus up to 8c2. Okay, so in order to sum up this series, I'm going to make a little change, that I'm going to write this 2c2 as 3c3, as 2c2 is also equal to 1 and 3c3 also has value 1, so I can replace this without any problem, without changing the actual value. It won't change the actual answer. But now I can use a property, a simple property of combinatorics, that is NCR plus NCR minus 1 is equal to N plus 1 CR, which is basically Pascal property. Okay, so very simple property of binomial coefficient. So by doing this, 3c3 plus 3c2 will be equal to 4c3. Okay, then 4c3 plus 4c2 will be equal to 5c3. And doing in the same manner, we can say by summing up this series by 7c2, we will be having 8c3, then 8c2. The final answer will be 9c3. Final answer will be 9c3. Okay, so we could do this problem directly. There can be like one more way to solve this problem, far easier than this I did, because I calculated each and every case and then summing up the series I got the answer. So I can write it directly as x plus y plus z and introduce one more variable, and I can write it this equation equal to 6. Why I did so? Let's say if t get any of the value, any non-zero value 1 2 3, in that case x plus y plus z will be equal to, it will be lesser than 6. Otherwise, if t gets 0, the value of assigned to t is 0, in that case x plus y plus z will be equal to 6. So we will be having a answer corresponding to this particular equation same as this particular inequation, x plus y plus z less than 6. The logic is that if t gets any value, in that case x plus y plus z will be lesser than 6, otherwise it will be equal to 6. So this can be done in how many ways? We have 4 beggars, so I just need to add one dummy coin, one lesser dummy coin, which is 3c3. So direct answer will be 9c3. Okay, so this is my final answer, 9c3. So we could do it directly by just introducing one extra variable, which is t. So in case of inequalities, we can do such manipulations in order to have a simpler approach to solve such problems. So let's consider one more inequality. Let's say I have x plus y plus z plus w is equal to 20. And I have constant that all these variables are non-negative integers. Okay, they can be assigned values like 0 1 2 3, anything up to 20. And one more constant, that this w must be lesser than 11. Okay, must be lesser than 11. So in how many such solutions we can have corresponding to these two conditions? So first approach can be make all possible cases for w is equal to 0 1 2 up to 10. Okay, then sum up all the cases. So if we have w is equal to 0, I will be having equation x plus y plus z is equal to 20. Okay, so in that case answer will be 22c2. Okay, there are 3 beggars, so one lesser dummy coin I need to introduce, that will be 22c2. If w is assigned 1, in that case x plus y plus z will assume value 19, so my answer will be 21c2. So going in the same manner, if I assign w is equal to 10, so x plus y plus z will be equal to 10. So one lesser coin, that makes 22c2. So summing up this entire series, I will get the required answer. So I can write down 22c2, 21c2, 20c2, and so on, 12c2. Let's say 13c2 plus 12c2. So I'm going to make little manipulation here in order to use the Pascal property. So what I will do, I will simply add and subtract 12c3. Okay, so now I can use the Pascal property again, that 12c2 plus 12c3 is 13c3, and again 13c2 plus 13c3 will be 14c3, and going in the same manner I can say this will get summed up and I will get 22c3, and my final answer will be 23c3 of this series. Okay, up to this. So my answer is sum of this entire series will be equal to 23c3 minus 12c3. Okay. Again, I can have one more approach to solve this particular inequality, which is the constant is x plus y plus w plus z is equal to 20, and all x, y, z, w are non-negative integers with w less than 11. So what I don't want that w becomes greater than or equal to 11. So what I'm going to do, I will simply write all the solution minus the solution where w is greater than 12. Okay, so if w is greater than 12, then definitely my x plus y plus z will be less than or equal to 9. Okay, so I need to find out solution corresponding to this particular equation. I will subtract this solution from the total number of solution, which is the total number of solution is 4 variables. Okay, so my answer will be total minus solution corresponding to this inequation. Let's start it. Okay, so total number of solutions are corresponding to this equation is 4 baggers. So I need to introduce one lesser coin, that is 3. So 23c3 is the total number solution minus corresponding to the solution of this inequation, which I just solved in the last question. X plus y plus z plus t equal to 9 by introducing one extra variable, which is t. So if t gets any value from 1, 2, 3, in that case x plus y plus z will be lesser than 9. Otherwise x plus y plus z is equal to 10. So again the answer will be one lesser coin, that is 9 plus 3c3. So my required answer will be 12c3. Okay, so I hope you like this video. You got the concept about Diophantine equation or corresponding to solution x plus y plus z equal to 20 non-negative integer solutions of this particular equation and equations. So let me know in your comments what else you demand from me. Thank you very much. Take care.